Welcome to the deep dive. Now, I have to admit, when I first saw Spring Boot scalability and load handling, it sounded, well, pretty heavy.
It can sound a bit intimidating, yeah.
But you shared this great summary, Spring Boot, scalability and load handling for beginners, just 3 pages, and it looks like it makes things really accessible.
That's the goal, to break it down.
Exactly. So our mission today is really to unpack these crucial concepts. What do they actually mean if you're building an app that needs to grow?
Right.
We want to explore why they're so vital and, how the Spring Boot makes them surprisingly approachable even if you're just starting out.
hmm
I love the analogy in the source material. Think of it like a restaurant, a popular one. How does it go from serving just a few people to, like, thousands without the kitchen catching fire or the wait times getting crazy?
That's a perfect analogy.
That's exactly what we're going to explore today for your Spring Boot applications.
And it's so important because this isn't just theory, you know? This is practical stuff. It's the foundation for building apps that are robust, professional, and actually ready for the real world right from the start, building for growth.
Okay, so let's dive into these core ideas. Because, we've all been there, right? A website slows to a crawl or an app just dies when everyone tries to use it at
Oh
once.
yeah, the dreaded slowdown.
Our sources do a great job clarifying scalability and load handling. So let's start with scalability. In simple terms, what are we talking about?
Scalability at its heart is really just an application's ability to grow. Simple as that.
Grow how, though?
Will grow to handle more users, process more data, manage more tasks, basically do more work without slowing down or becoming unstable, like your restaurant analogy. It's expanding capacity without making people wait ages. And the source points out there are two main ways this happens. First, there's vertical scalability.
They're like going up.
Exactly. You add more power, more CPU, more RAM to your existing server. Think of upgrading your restaurant's small oven to a huge industrial one.
Okay, one machine, just bigger.
Right. It works, but you eventually hit a limit. You can only make one oven so big.
Makes sense.
Then there's horizontal scalability, and this is really key for Spring Boot. Here, you add more servers, more instances of your application.
Okay, like opening new branches of the restaurant?
Precisely.
Yeah.
New, identical locations sharing the customer load. Spring Boot is fantastic at this, especially for web apps and microservices, because it's designed to spread work across many instances easily.
Okay, so scalability is the capacity to grow. But what about when that growth actually happens? Like the flash sale starts and bam, everyone hits the site. That leads us to load handling, yeah.
Exactly right. Load handling is about managing that immediate pressure, that burst of activity when tons of users or tasks hit your app all at once.
It's like the coffee shop rush.
Perfect example. Good load handling is like that efficient coffee shop managing the morning rush. Everyone gets their order fast, the baristas aren't overwhelmed, the line keeps moving. It's all about staying responsive under load.
So they work together, scalability and load handling.
Absolutely. And for beginners, getting these concepts is so fundamental. Why? Well, first, it keeps your apps fast and reliable. That's crucial for user experience as you get more popular.
Nobody likes a slow app.
Nobody. Second, it helps save money, especially in the cloud. You use resources efficiently, not paying for massive servers all the time.
Right, pay for what you use.
Third, it makes your apps robust. They don't crash during those sudden traffic spikes. Fewer emergencies.
That's a big one.
And maybe most importantly for beginners, it lets you build professional apps that can actually grow without needing, a massive rewrite later. You build growth in from the start.
So it's really about building something solid that can handle success without you needing like decades of experience on day one. That's pretty empowering. Okay, this is where it gets really cool. The sources say Spring Boot isn't just talking theory. It gives you actual tools, built-in features to make this happen. So how does it do that? What are the nuts and bolts?
Yeah, so one of the biggest things Spring Boot enables is microservices architecture.
Microservices. We hear that term a lot.
We do. And basically, instead of one huge monolithic app doing everything, you break it into smaller independent services. Each one handles a specific job.
Like what?
Like user logins might be one service, the product catalog another, payments a third. Think of them like separate food trucks instead of one giant restaurant kitchen.
Okay, I like the food truck idea.
The beauty is, if your payment truck gets swamped during a sale, you can add more payment trucks scale just that one service without touching the others. It's targeted scaling.
That makes a ton of sense. So you're not scaling everything unnecessarily. And building on that idea of spreading the work, load balancing comes into play, right?
Exactly. Load balancing is the traffic cop. It distributes all the incoming user requests across your multiple servers or microservices, your different food trucks.
How does Spring Boot help there?
Well, you can use tools like Spring Cloud, which has load balancing built in, or integrate with external load balancers. The point is to prevent any single server from getting overloaded.
Like opening more checkout lanes at the supermarket.
Perfect. Splitting the long line across multiple cashiers so everyone gets served faster. If you launch a product and get hit with traffic, the load balancer spreads it out. Smooth experience for everyone.
Okay. What else is in the toolkit?
Caching. This is huge for performance.
Right, storing data temporarily.
Exactly. You store frequently accessed data, maybe popular product details, user session info, and really fast memory, using tools like EHCache or Redis, which integrates easily with Spring Boot.
So it's like keeping the most popular menu items prepped and ready to go.
Precisely. Instead of cooking that popular dish from scratch, every single time someone orders it, you have it ready. It drastically reduces the load on your database because you're not constantly asking it for the same stuff.
I can see how that speeds things up. Showing bestsellers instantly, for example.
Thousands of users see it instantly. Database barely notices.
What about tasks that just take longer, like sending out a welcome email or generating a big report? Those can't be instant.
Good question. That's where asynchronous processing comes in. Spring Boot makes it easy to handle these time-consuming tasks in the background.
So they don't block the main flow?
Exactly. The main application thread stays responsive to the user. It's like the chef handing off the side dish prep while they focus on plating the main course. The customer gets their meal quickly, the sides get done without slowing down service.
So like a user signs up, gets immediate confirmation.
And the welcome email gets sent off in the background without making them wait on the sign-up screen. It really improves load handling during busy times.
Okay, one more.
Yeah, a crucial one. Database optimization. Even with caching, you still hit the database. Spring Boot, especially with Spring Data GPA, helps you make those database interactions really efficient.
How so?
It helps you write queries that fetch only the data you actually need and do it quickly. Think of it like asking a librarian for one specific book by its exact call number.
Instead of saying, show me everything about history.
Exactly. You avoid making the database do unnecessary work, which reduces strain and allows it to handle more users concurrently. Fetching just a username for a profile page, not their entire life story from the database.
Wow, okay. That's a pretty comprehensive set of tools Spring Boot offers.
It really is.
So let's connect this back to the problems beginners face. Our sources highlight common headaches that these features actually solve. What are those big pain points we can avoid?
Right. The sources list about 5 key ones. First, the obvious one. Slow performance during high traffic. Your app just grinds to a halt when it gets popular.
The worst.
Load balancing spreads the requests. Caching avoids hitting the database constantly for the same popular stuff. Keeps things zippy.
Okay, makes sense.
Second, crashes under heavy load. That sudden spike doesn't just slow things down. It can actually kill the app.
Nightmare scenario.
Microservices help isolate failures. One part getting hammered doesn't take down the whole thing. Load balancing prevents any one server from melting down. Async processing stops background tasks from clogging the main pipes.
So, more resilience.
Much more. Third, high resource costs. An inefficient app just eats up server resources, and that costs real money, especially in the cloud.
Yeah, those bills can climb fast.
Caching and database optimization cut down resource use per request. Horizontal scaling means you add servers only when needed, instead of running giant, expensive ones all the time. Caching user sessions alone can save a lot on database load.
Smart scaling equals cost savings. Got it.
Fourth, just the sheer difficulty growing the app. For a beginner, taking an app that works for 10 users and making it work for 10,000 can feel impossible.
Feels like you'd have to rebuild everything.
But with things like microservices, you can scale specific parts. If payments are the bottleneck in your growing e-commerce app, you scale just the payment service. Spring Boot's tools make adding capacity or optimizing less daunting.
So you can evolve it more easily.
Exactly. And fifth, tying it all together, poor user experience. Slow, unreliable apps just drive users away.
Ultimately, that's what matters most.
Right. Scalability and load handling ensure your app stays fast and dependable as you grow, keeping users happy. Load balancing during a surge means quick page loads, not frustrating waits.
Okay, that paints a really clear picture of the why. But for someone starting out, the big question is always the how. How do I actually use these things? Our sources suggest it's surprisingly straightforward with Spring Boot. Is it really that simple?
It often is, relatively speaking. That's a core strength of Spring Boot. For caching, you basically add a library like ehcache or Redis as a dependency in your project config file. Add a few annotations, and Spring Boot handles a lot of the setup.
Like plugging in a module.
Pretty much. It's like setting up that quick serve counter we talked about. For database optimization, using Spring Data JPA is often as simple as including it in your project. It gives you simpler ways to define database interactions that are often quite efficient by default.
Like getting a better filing system for your library.
Good one. For asynchronous processing, you literally enable it with a single annotation, like add enable async, in your main configuration.
One line.
Often just that to turn it on. Then you mark specific methods as add async. It's telling Spring Boot these tasks can run on the side, like hiring extra staff for those background jobs.
Okay. Microservices sound more complex, though.
They are more complex conceptually, but Spring Boot and Spring Cloud provide tools to manage the infrastructure. You add Spring Cloud dependencies, configure how services find each other. It streamlines setting up those separate food stalls.
So it handles some of the tricky wiring.
A lot of it, yeah. And for load balancing, if you're using Spring Cloud, it can automatically handle distributing requests across instances of a service. Or you configure an external load balancer by giving it the addresses of your servers. It's like defining those checkout lanes and telling the system where they are.
It really does sound designed to lower the barrier to entry for these powerful techniques, which is great for beginners.
Absolutely. Simple tools helps you build reliable, fast apps, can reduce cloud costs, prepares your app for real growth, lets you focus more on features, less on complex infrastructure initially.
It can't all be magic, right?
Yeah.
Are there things beginners should watch out for? Pitfalls?
Definitely. That's a really important point. It's accessible, but not foolproof. With caching, you have to think about cache invalidation,
Meaning?
meaning making sure you don't serve old, stale data. If a product price changes, your cache needs to know. Otherwise, you're showing the wrong price, like that restaurant advertising yesterday's specials.
Right, got to keep it fresh.
With microservices, remember they add complexity. Managing multiple services, deployments, inter-service communication,
Yeah.
it's more moving parts.
Yeah.
So the advice is often, start simple, maybe monolithic, and only break out microservices when you really need that independent scaling. Don't over-engineer from day one.
Good advice. Don't build 10 food trucks, one will do for now.
Exactly.
Okay.
And finally, load balancing implies having multiple servers. More servers mean more infrastructure, which usually means more cost. You need to plan it and scale smartly so you're not just burning money on idle servers. Balance performance with cost.
So powerful tools, but use them wisely. Understand the trade-offs.
Precisely.
Okay. So to wrap up for the listener, you should now have a much clearer, I think, quite powerful understanding of how you can build applications that genuinely scale and handle those big moments, those traffic spikes. And it's largely thanks to Spring Boot making these features accessible. You're essentially equipped to build apps that are professional, resilient, and truly ready for growth.
Yeah, you really are. And this brings up, I think, an interesting question to ponder as you move forward. While Spring Boot simplifies the how, the real art, the next level, is understanding when to apply each specific technique. So as your own application starts getting users, starts feeling different kinds of load, how will you decide? When is the right moment to add more caching versus, say, thinking about breaking out that first microservice? That judgment comes with experience, but thinking about it now is key.
That's a fantastic question to think about. When to pull which lever? Great food for thought as you continue exploring based on what we've discussed today.